What a MAC address. What is this MAC address? As I said, NIC, Network Interface Card. Every NIC has a MAC address. For example, so I have ncpa.cpl. It opens directly a network adapter settings. See, and this is my adapter. If you see on the adapter, there is a MAC address. So this is called physical address. Okay. So if you go to this NIC, even it is a virtual, so it is a MAC address. Okay. Every NIC, either it is wired type or wireless type, every NIC has MAC address. What is MAC? Media Access Control. MAC address is also called as physical address or hardware address. MAC addresses is also called as physical address. When you see it's a physical address means automatically, sir, it is you are saying MAC address, but it is showing physical address, right? If you see here, it is physical address it is showing. Of course, it is MAC address only. Okay, either you use MAC address or what is MAC address or physical address, it is MAC address only. Okay, or hardware address. It is a fixed address, it cannot be changed. Like your IP addresses, we can change IP addresses as per our network, but MAC addresses we cannot change. And these MAC addresses assigned by the manufacturer of NIC. These MAC addresses assigned by the manufacturer of NIC. Okay. So this MAC address, when I say address means it is in some representation, right? It is. If you write the MAC address in binary, it is 48-bit. But actually MAC addresses in the hexadecimal format. It is look like this one. Okay, I can show my MAC address also. See, this is my MAC address. Okay, it's like that one only. It is 12 hexadecimal numbers. Even 0, 3, A, everything is hexadecimal number here. It's not alphanumeric number. It is hexadecimal number. So what is a MAC address? Every NIC has a MAC address. It is fixed address and also called as physical address. It is given by the manufacturer of NIC. For example, I purchase a Realtek NIC or TP Link NIC. Okay, it is wide or wireless, anything. Okay, so TP Link or D Link or Intel. So what happened? The who manufactured that NIC give that MAC address inside. That's how it is unique. In this world, only one MAC address is existing. MAC addresses are not repeatable for the physical computers or physical any physical device. The MAC addresses are not repeatable. Okay, I have a laptop. My laptop, my wireless adapters, NIC is the only one MAC address in this world. It's a unique address. Okay, guys, understand what is a MAC address?
Yes, sir.
Very good. The MAC addresses can be checked using a commands like a getmac. Okay, use the command like a getmac, or you can use ipconfig/all. Okay, getmac will give you your MAC addresses and the device names. Of course, we cannot understand which device it is what. Okay, so if you go to ipconfig/all, it will give your IP address, subnet mask, default gateway, DNS server addresses plus your MAC address, your device name and your MAC address, and further details also you are getting. Okay. And another one I already showed. So go to the adapter ncpa.cpl, double click on the adapter details. You can find the MAC address. Okay. So this is how to check the MAC address. Actually, I want to continue with the MAC address kind of stuff. So then I will use this IP address also. I want to complete this MAC address, IP address kind of stuff. So then I am trying to finish this part because this has become more important than any other. Why I click? Okay. So then what is the other things we can discuss? We'll see. So here it is. We discussed about a MAC address, then we will see about it is. So difference thing is like this. Difference between IP address and MAC address. You know what is this highlighted point, guys? It is always you have to remember that is we use IP address for all communications. IP address mainly IPv4. We have a protocol suite called a TCP/IP protocol suite, and we are connected in star topology, not a mesh topology, not a bus topology or ring topology. We use star topology. We use UTP cables, twisted pair cables. In the under that one, mainly UTP type cables only we use it. Okay, that's why I highlighted. We'll come back again. So what is an a MAC address? MAC address is a physical address and it is on your NIC. Okay, whether it is wide type of NIC, wireless NIC, on the NIC, it is MAC address is there. And which is who is given that MAC address? Manufacturer of that NIC. It is 48-bit represented in 12 hexadecimal. We can't change the MAC address. Of course, we can do some duplicating MAC address. That is software wise, you can do it. That is different concept. Like a spoofing possibility is there. Then what is the IP address? IP address is a logical address. MAC address is physical address. IP address is logical address. What is an IP address? IP address is uniquely identify a device in the network. IP address is uniquely identify a device in the network. IP addresses can assign or given or configure by manually or automatically. IP addresses can be assigned or configured to the NICs. Manually we can configure or you can get automatically. The DHCP server assign IP address to the client device automatically. Guys, look at this. I have an adapter. For this adapter, I can assign an IP address manually. Look at here how to assign an IP address manually. So what I have done, I double click on the adapter, go to the properties, IPv4, you can see there is IPv4 properties. Okay. So if you give like this, obtain IP address automatically means you will get an IP address from the DHCP server. The point is you will get an IP address from the DHCP server. Okay. So if you select this first option means in the network there is a DHCP server. Maybe it can be your router. It gives IP address to this adapter. If this adapter is connected to a DHCP server, then DHCP server will give an IP address. Important is on the adapter, this option should be selected. Okay, this is automatic. Obtain IP address automatically, obtain DNS server automatically. This is first. What is this second one? What is the second one? You want to configure manually. So you have to say what is your IP address, subnet mask, default gateway, and DNS server. By yourself, you want to give. So that is called a manual. Okay. Use following IP address. Use DNS server kind of stuff. So I'm selecting use following. See, this is we can able to type something. Okay. We can able to type something here. But if I select this one, I can't type it. It's not selecting. If I'm giving some IP address. Okay. Some IP address based on my network. I'm giving this one. Okay. So now it is, I configure an IP address manually because I given. So it is DHCP enable now. DHCP enable now. Now it is came. You look at this. DHCP enable now means you configured IP address manually. Okay. If you see IP address, subnet mask, and default gateway, DNS server address, which is still showing some error kind of stuff. So we'll try to, yeah, now it is good. Okay. See, DHCP enable now means this adapter is assigned an IP address manually. And you got IP address, subnet mask, default gateway, and DNS server. And you may not see in the DHCP server address. Okay. So this is configuration of IP address manually. Understand, guys, how to configure IP address manually?
Yes, sir.
Okay. This is another adapter. Actually, this adapter is connected to the DHCP server. Okay. This system with this adapter, it is connecting outside. In my network, I have a DHCP server, which is nothing but my Wi-Fi router, which is nothing but my Wi-Fi router. So this DHCP server gives me an IP address to my adapter. Okay. So what happens? See the details. See, I got an IP address. See, I will show the properties. IPv4. See, IPv4 properties. You can see obtain IP address automatically. Obtain DNS server address automatically. So what will happen with this setting? Our adapter will get an IP address from DHCP server. Okay. So if you see this one, DHCP enable, yes. DHCP enable, yes. For this adapter, I went to the details. DHCP enable, yes, means you got IP address from DHCP server. DHCP server, P. Okay. You got IP address from DHCP server. What is my IP address? And what is my subnet mask? Default gateway, DNS server address. You see, this is my DHCP server. This is my DHCP server address. This is my DHCP server. From here, I got this IP address. DHCP server configured an IP address to my adapter, to my system exactly say. Okay. So DHCP enable, Yes. And if you see the DHCP server address, it means you got an IP address from the DHCP server. Who is your DHCP server? This is your DHCP server. Guys, understand how to get an IP address, like how to configure our adapter to get an IP address from DHCP server. Okay. DHCP server assign or configure IP address to the client devices automatically. Again, IP addresses can be changeable by manually or automatically. Guys, I connected in our office. I got one IP address from the office DHCP. When I go to the home, in my home I have Wi-Fi router which is act like a DHCP server. I will get another IP address in my home. If I connected from home, then I will get another IP address. IP addresses can be changeable automatically or manually. See, this is my adapter. I have some IP address. Then I can able to change it. See, I go again. I'll go to this manual. If I want to change this, I can change it. Manually, I'm changing it. Anything you can put it. So I don't mind about it. Okay. This is, I'm changing an IP address. See, different IP address I assign. See, manually I change IP address. Automatically means this is auto configured IP address for this adapter. So when I go to the home, from their DHCP, this IP address will change. So IP addresses can changeable by manually or automatically. IP addresses define logical network. You know, in our office, we have a lot of computers. We make them like this group. This particular department should communicate each other. And this particular department, okay, this particular department should communicate each other. This particular department should communicate each other. It means you have computers here, you have a computers here, will connect and they will communicate each other. You have a computers here and we have a computer. All are connected into same physical network. All are connected to same physical network. But logically, both are different networks. Two departments in the same physical network. And I make these people can communicate each other. These people can communicate each other. Okay, but they should not communicate each other. So how can I make it possible? So I make this an IP address one different network and assign some other IP different network. So logically I divide these networks separately. That's why we are using IP addresses. Why not MAC addresses? MAC addresses are more unique. You need to buy extra MAC addresses to communicate. Okay, but MAC addresses we cannot divide them logically. But IP addresses, we can divide a physical network into different logical networks. Okay, IP addresses. Using IP addresses, we can create different logical networks in the same physical network. That is the high power of IP address. That's why we are using an IP address. Okay, every device must have an IP address to communicate in the network. Every device must have a IP address to communicate in the network. Without IP address, you can't communicate. All communications in the network is by IP address only. Okay. Even you can get it out, sir. I open Java T point. I've opened the Google.com. I've opened this Microsoft.com. I've opened WhatsApp.com. Okay. So All we are communicating with the names, but actually we are communicating with the IP address only. If you look at here, when I'm trying to ping www.google.com server, then I'm getting first IP address. Then with IP address, I'm communicating. So there is a DNS server actually gives an IP address of www.google.com. So then I know the IP address of google.com, then I'm communicating. Okay. So all communications by IP address only. All communications by IP address only. And IP addresses are two versions, IPv4, IPv6. IPv4 is 32-bit in binary, IPv6 is 128-bit in binary. It represents in decimal format, IPv6 represent in a hexadecimal format. Okay, guys, understand about few points about IP addresses. No one is responding again. Guys, do you understand anything about IP address? And also see the differences. MAC address is a physical address, IP address is logical address. IP address is uniquely identify a device in the network, not unique address. It is IP address is not unique address. Uniquely identify a device in the network. With the help of IP address, we can identify the devices in the network with a some number kind of stuff. IP addresses can changeable. IP addresses cannot be changeable. IP addresses cannot be, sorry, MAC addresses cannot be changeable. IP address can be changeable. We can configure IP addresses manually or automatically by the, we can assign or configure the IP addresses manually and or automatically by the DHCP server. MAC addresses already assigned by the manufacturer of that NIC. Okay. And IP addresses are IPv4, IPv6, two versions are there. Okay. In IP MAC addresses, there is no versions, only one version that is called a only single version it is. So 48-bit, 12 hexadecimal. That is the major differences between IP and MAC address. Guys, understand up to here.
Yes, sir.
So the next one is IPv4 and IPv6. IPv4 is 32-bit, IPv6 is 128-bit. IPv4, the total IPv4 addresses are 4.3 billion IP addresses. IPv6 is 3.4 billions of IP addresses. IPv4 is represented in decimal format like this. IPv6 is represented in the hexadecimal format. This IPv4 32-bit is divided into four parts. Okay, each part we call it as a octet. Each part we call it as a octet. This is 32-bit now. So 32-bit divided by 4 means 8 bits. So it is called as a octet. It is like a first octet, second octet, third octet, fourth octet. If you see, this is the first octet, second octet, third octet, fourth octet divided by dot. Divided by dot. 4 octets separated by dot. Okay. The total IP addresses, the range is start with a 0.0.0 and finish with a 255.255.255. Okay. So this is IPv4. Again, I will continue IPv4, guys. Then I will show some things in IPv6. Represented in hexadecimal format means ఇక్కడ ఉండాలిగా. So, okay. One hexadecimal is in the binary represented with the 4 binary bits. 128 by 4 is 32 hexadecimal. 4 hexa as one block separated by a colon means uh, IPv6 having 8 blocks. Each block contains 4 hexa numbers. Okay, it is the some point. Of course, we have a different things. In IPv4, we have a classes, but IPv6, our direct classification is there, like link local IP address, private IP address, global public IP address kind of stuff. Global unique addresses, private IP address, link local IP address, multicast IP address, any cast IP addresses are there. In IPv4, we have a direct classification. So we have a classification, class A, B, C, D are there. Okay. Okay. We'll come back to the IPv4, guys. It is the starting IP address is 0.0.0 and up to 255.255.255. It's a totally 5 classes. Sorry, it's a totally 4.3 billion IP addresses. It is divided into the 5 classes. Okay. It is based on the first octet of IP address. These are the classes. Okay. IPv4 is divided into 5 classes. The entire range from 0.0.0 to the 255.255.255.255. The entire range is divided into 5 classes. There is a 5 classes: class A, class B, class C, class D. The class A is ranging from 0 to 128. Class B is 128 to 191. Class C is 192 to 223. Class D is 224 to 239. Class E is 242 to 55. Okay. So these are the 5 classes. But for a class A, it shows like 1 to 126. It represents like there is a few addresses. You don't use it. Like 0.0.0 and 0 series, 127 series and 127.0.0.1. We don't assign. We don't use means we cannot assign to any device. These are the reserved addresses for different purposes. Like 127.0.0.1 reserved IP address, use it for loopback or local host address. For self-testing, self-host accessing, self-host service accessing. Okay, host service accessing purpose. Okay, and 0.0.0 also used by certain services. Okay, like a default no host kind of services are there, so we cannot use it. And also we cannot use the class E reserved for R&D, and we cannot use class D also. It's multicast used by certain protocols. We cannot assign. What we can able to assign? Class A, class B, class C are unicast addresses which we can assign to our devices except 0.0.0 and 127.0.0.1 and entire 0 series, entire 127 series. Guys, again, I'm going back once. Important thing is what is a MAC address? What is an IP address? Okay. What is a IP address? Difference between MAC and IP address. One or two major differences between IPv4 and IPv6. And IPv4 classification, the total range and the classification, class A, class B, class C, class D, class C ranges. Okay, that is a major point. Say. Identification of IP address class. Because when you see an IP address, see the first octet of IP address. See always first octet of the IP address, first one. And if it is ranging in this. So based on that, you can get it. See, here it is 134. See, where is 134 is there? This is a 134 range. Okay, it is 134 is between this range. So it is class B. Okay, 156. 156. Again, class B. I don't mind what is showing here. I will check only the first octet. 10. 10, class A. 194. 194. Class C. 227. Class D. Okay, like this. Identify which class of IP address it is. Okay, guys, understand IP address and IP address classes. What is the importance of IP address? What is the importance of IP address, guys? To identify device in the network. To identify device in the network. That is a major importance of an IP address. Okay. These IP addresses divide into network and host portions. Already I told IP addresses. By the IP address, I can define logical network. Logical network. One big physical network, I can divide them in logically with the help of IP address. How it is? IP addresses are by default. There is a network and host portions. If both devices IP address matches, one second, guys. Sorry, guys. Okay. So the point is, just I'm trying to speak faster. So then time is more important now for your batch. Okay. This is okay. IP address is divided into network portion and host portion. For class A, the first portion is network portion. Class B, first two portions are network portions. Class C, first three are network portions. If devices want to communicate in the network, their network portion must be same, host portion is different. Guys, if you look at here, there is a three computers are configured with an IP addresses. This is the first PC1 IP address, PC2 IP address, PC3 IP address. You see, this is the first portion because if you see the first portion, it is class A. Class A network portion is first portion. Okay. To make sure that is the first portion matches, these systems will communicate. For third person, see, for third PC, it's a different one. It's a 110, it is 111. It's a different one. So these two are can communicate each other, but this is cannot communicate to these PCs. Same it is, see, it's a class B network. The first two portions are network portions. So first two portions are network portion means for every device, the first two portions must be matches. Otherwise, what happen? They can't communicate. See, it is here. It is second portion is different. Here, the first portion is different. But PC1, PC2, PC3, all the first portions are same. First and second portions are same. So they will communicate each other because it's a class B. And this is class C. The first three portions are network portions. See it? See the first two systems having all three portions are same. But if you see here, it is this is different. Third portion is different. Its second portion is different. Your first portion is different. You must the first three portions must be same. Okay? If not, it won't communicate. This is a different network. So PC1, PC2 can communicate because their first three portions are same because it's a class B. PC3, PC4, PC5 cannot because of there in the network portion changes there. Okay? The remaining host portion entirely change or at least one difference is also acceptable. Okay? But guys, you have a two systems. These two systems must be connected. Okay? So you want these two systems want to communicate each other. They must be connected through a cable or a wire kind of stuff. Like this. Two systems want to communicate each other. There must be a connectivity. Wide connectivity or wireless connectivity. There must be a connectivity. And second one is both systems should configured with a IP address. In that IP address, their network portions must be same. Okay, their network portions must be same. And host portions are different. Not required to every host portion is different. At least one host portion of the network is different is enough. Okay. So then try to communicate. Just try to ping from PCA to the PCB IP address. So then you will understand. So there is a communication between A to B is there or not. Same thing in the B. If you do ping, so then you can get it. Okay. So point is, guys, first device must be connected wide way wireless any which ways. Okay. And you must give IP address. Either physically can able to give it. Okay. So physically you can assign an IP address means like a manually, or you can get an IP address from DHC. The condition is the IP address network portion must be same to make a communication between the devices, and host portion is different. One second, guys. చాలా ఉన్నాయి తింటాను క్లాస్లో ఉన్నా. Okay, sorry guys. Where are we? Yeah, I will tell up to here this point, subnet mask, and I will give you a 10 minutes break. Then I will explain again. Guys, we know by understanding, we can understand there is an IP address. It contains IP address, network portion, and host portion. Okay, there is an IP address, there is a network portion, and host portion. But how system will divide network into network portion? How the system will divide IP address into network portion and host portion? So your system use subnet mask. Guys, when you are assign an IP address, okay? So I'm checking an IP address. See, there is an IP address, and also you can see the subnet mask. What is the use of this subnet mask? System use this subnet mask to divide this IP address into network and host portions and tells network ID. As I said, these two IP addresses are assigned. Okay, the system's IP addresses are assigned. What our system will do? It uses the subnet mask. It uses the subnet mask. It divides this IP address and find a network ID. Okay, so this side also subnet mask. It find a network ID. If this network ID and if this network ID matches, both will communicate each other. Both will communicate each other. Okay. So what is the use of this subnet mask? The system use the subnet mask to find the network ID and it divide the IP address into network and host portions. Find the network ID. If both the system network ID matches, they will communicate each other. They will communicate each other. Okay, guys. And these are the default subnet masks. These are the default subnet masks. Class A subnet mask is 255.0.0.0. Class B, the subnet mask is 255.255.0.0. And Class C subnet mask is 255.255.255.0. So these are the default subnet masks. Okay. So somewhere I have to write again. So then I will try. Remember IP address IPv4 classes. Okay. Next subnet mask default subnet mask. Okay. For classes. Next day I will explain once revise all these things. We'll try this. We discussed about IP address, MAC address, classes, subnet mask, and default subnet mask. Okay. What is the help? What is the use of subnet mask? System use subnet mask to divide your IP address into the network and host first, and then it will tell network ID of your IP address. And both side network ID matches, they will communicate each other. Not matches, they won't communicate on the same network, same local network. Okay. So this is about your subnet mask, guys. Okay. I'm not going with all these things. Okay. Um, what is the leftover part? Yeah. These are the private IP address, public. It's okay. So take a break, 10 minutes break. Okay. So take 10 minutes break. Come back at 4:45.